Hello. Hello. Good afternoon, everybody. So let's start, guys. So last time I started to teach logic operations. So we have some instructions. We have some instruction to do logic operations. And I told you what I mean by logic operation. I told you it means if you have two registers or if you have two words, when you do logic operation, so actually what you are going to do is going to be bit by bit. So, and the logic operation we have, let's start the lecture, guys. So the logic operation we have, you can do logic AND, you can do logic OR, you can do XOR, bit by bit. Is that okay? So, so we have instructions for AND, for OR, for XOR, okay? Doing bit by bit. And more importantly, I told you these operations are very important. We are going to use them all the time. So how can we use this operation? This operation should be used for one of two things. Very important. We're going to use it especially starting from chapter 3. We're going to use it all the time. This one can be used for bit manipulation. Manipulation. And also it can be used if you want to check bits. So what do you mean by bit manipulation? I'm going to tell you what I mean. What I mean, if you have a word and I wanna change one bit or a number of bits without it changing the other bits. Okay, so I want to manipulate some bits. Here I give example for one bit, but for sure you can use the idea. I use the idea for more than one bit. So here I want to, for example, this bit. So I want to change this bit. So what do you mean by want to change? It means one of three things. I want to put 0 here in this bit without it changing the other bits. Okay, so here clear the bit. Or you want to put 1, so you want to set this bit and don't change the other bits. Or you want to toggle. I want to toggle this bit and don't change the other bits. This is what I mean by bit manipulation. If you have a word and I want to change some bits without changing the other bits, okay? So this is important. The other thing, in order to do that, we use logic operations. The other thing is if I want to check some bits, what it means? It means I have this word and I want to check this bit. I want to check this bit. I want to know if this bit is this is 0 or 1. I want to check this bit. Is that okay? So we're going to use logic operation for one of these two things. But why this is important? You are telling us we're going to use it all the time. For sure, we're going to use it all the time. Why? I'm going to tell you why. Because as you will see, starting from chapter 3, when I say I have a word, so actually, for example, and then I want to change only one bit. Actually, as you will see in chapter 3, this bit is actually somehow connected to an external pin. Is external pin, okay? And then I can connect here in the external pin, I can connect something like an LED, okay? So actually, as you will see in chapter 3, if I want to turn the LED on, all what I have to do, I have to write 1 here. Once you write 1 here, the hardware is gonna put here 5 volt, and then you turn it on. Is that okay? Also, if I want to turn it off, all what I have to do, I have to put in this bit, I have to put 0. Once you do that, this pin is going to have 0 volt, and you turn the LED off. That is why, what I'm explaining here, why it is important. If you have a word to change only one or few bits, don't change the other ones, okay? So here in this case, because I just want to change this pin, I want to turn this LED on or off, okay? Maybe the other pins here are connected to other pins, but I just want to change only one pin. Any question, guys? Very important. Okay. Also, this is why bit manipulation is important. Why we are going to use it all the time. Okay. Now, why if you want, I told you we are going to use also to check some bits. Okay. Why this is also important? Why I want to check some bits again for the same reason, but the other way. For example, if I have here a pin and this pin is actually input. This one was output pin. Okay. Anyway, I'm going to give you more details later, but for now, you have, for example, a switch. And this switch, this is actually, should be something like, let me, for example, here, this pin here, you should have a resistance. You have here 5 volt, you have here a switch, and then you have ground here, okay? So actually what happens, if the switch is open, so you are gonna have 5 volt here, okay? And if the switch is closed, actually, you are gonna get 0 volt here. Is that okay? So actually we have, again, forget the details. That's what I'm gonna explain in chapter 3. What I'm explaining now, guys, we're gonna use logic operation to check some bits and manipulate some bits. What I'm explaining now, it may be a little bit early, but I want you to understand why I need to check some bits, because in this scenario, same thing, you have a word, okay? And then this bit somehow using the hardware is connected to 1 bit, so that if there is a 0 volt here, there is a 0 volt here, so actually this pin is 0, okay? So if the switch is connected, you are gonna put here 0 volt, and the hardware is gonna put logic 0 here. And if the switch is open, so here, this pin is gonna have 5 volt, and the hardware is gonna put here 1. So that means I have a word, I need to check a bit. That's it. Why? To know what is the status of this external pin, to know if the switch is open or closed. Is that okay, guys? So now, conclusion of what I said. Number 1, logic operations are used to manipulate bits and to check some bits. That's number 1. Number 2, this is used as I said here. If you have like some external circuit and you wanna put 0 here or 5 volt here, or you have a switch and you wanna know the status of the switch. So now I'm gonna explain how can you do bit manipulation. I explained last time, but I'm gonna repeat it today so that I can proceed. Also, how can you check some bits using logic operations? Okay. The idea is that, number 1, how can I set a bit? Okay, it's not complete. I have to say, I need to set a bit, and also I should not change the other bits as well. Okay, so we don't have an instruction to work on a bit. Most of the instruction we have, you have to work on 32 bits to 32 bits. We don't have an instruction to manipulate 1 bit. That is why I'm going to use right now an instruction for 32 and 32 to manipulate bits. You get what I'm saying? So if you want to set a bit, so you have to use logic OR. Why? I'm going to tell you why. For example, if I have this one here, and then I wanna set this bit. All what you have to do, guys, you have to put here 1, you have to put 0, 0, 0, 0 everywhere, and then you have to do logic OR. Why? Because 1 or anything, I'm going to get 1. 0 or anything, no change. I'm going to get the same thing again. This is how OR works. This is how the people invented OR. Or 1 or anything, I'm going to get 1. So it's guaranteed what I'm going to get here, I'm going to get 1 here. Okay? So the location of the bit I want to change, I have to put 1 here. Or the bits I want to set, I have to put 1 in the position of these bits. Here I give you example for 1 bit. Can I use it for more than? For sure you can. So for example, if I want to manipulate these 2 and this one as this one, you can. Okay, guys? Okay. Also, this number here, we'll call it a mask. You should be familiar with this term, a mask. What mask you have to use here, okay? So in case of OR, the mask I have to use is the bit you want to set, you have to put 1. The bits you don't want to change, put 0. Okay, guys? Any questions? This is for OR. Okay? Okay, now let's go for number 2. How can you flip bit or flip some bits? Okay? In order to flip some bits, that's why XOR is used. XOR. I'm going to tell you why. For example, it's the same example. If I want to flip this bit, so this bit, for example, I'm going to call it P0, P0. I want to flip this bit and I don't want to change the other bits. Simply, the bits you want to change, you have to put 1. The bits you don't want to change, you have to put 0s. Is that okay? So in this case, This is how XOR works. Okay, XOR works this way. If you have 1 and the X, I'm gonna get X prime. If you have 0, and X, I'm gonna get the X. So 0, no change. 1 is gonna do a flip bits. This is by definition. That's how XOR is. Yes.
Is there any reason why you have to use it on every single bit right? The logic gates, or why couldn't I just do like inverter just on that first bit?
That's a very good question. The reason is, so again, let me answer the question. So the question is, why you have to do the operation on 32 bits? Why you don't do it only in 1 bit? Simply because our processor can only work on 32 bits. You got what I'm saying? It cannot work on individual bits. Only all the operation we have, addition, multiplication, most of the operation we have, you have to work on hardware is gonna do that. I think if you want to work on individual bits, it's going to be too complicated for the hardware. That's why you have to work, because all the operation we have, it has to be on 32 bits. Okay?
Thank you.
So here, this is how XOR works. So the bit you want to flip, I have to put 1 here in the mask, and then you have to put 0 in the bits you don't want to change. So I'm going to get here B0 prime, then I'm going to do 0, 0, 0. Is that okay? One of the programs I'm going to teach in chapter 3 is flashing LED. So we're going to have an LED. I want to do flashing. Turn on, turn off, turn on, turn off. So again, this LED is connected to 1 bit. So all what I'm going to do is I'm going to flip the bit, wait 1 second. Flip the bit, wait 1 second. Flip the bit, wait 1 second, and so on. By this way, I can see flashing. Because every time you flip the bit, so the bit is going to be 0 for 1 second, 1 for 1 second, 0 for 1 second, 1 for 1 second. That means the external pin here is going to be 5 volt for 1 second, 0 volt for 1 second. So it's going to be flashing. Turn on, turn off, turn on, turn off. That's what we're going to do in chapter 3. Any questions? The last one here, and number 3, and pay attention to this one because there is a small difference between this one and what I explained here. Okay? In case of and. So and is going to be used if you want a clear bits. Again, these are the 3 operations we need: set, clear, flip. So now if I want to clear some bits and don't change the other bits, so how can I do this one? Again, the bit you want to change, you have to put 0. Is that okay? The bits you don't want to change, you have to put once. Why? Because this is how AND works. 0 and anything, I'm going to get 0. 1 and anything, I'm going to get once. This is how AND works. Okay, guys? Yes. So you can make the mask. This is the mask. You can make the mask this way. Okay? And you can use normal AND. Normal AND. Okay? However, there is something confusing here. Or I want to make it like a standard. Because if you go back 2 slides here, in case of, if you want to set some bits, the mask, if you have the mask 1 means you set 0, no change. Okay? If you come here, it's the same thing. What you want to flip is 1. What you don't want to change is 0. But here is the opposite. Again, this is because of how AND works. Okay, guys? So in the first question in the lab, you are going to use the normal AND. But in the second question, you have to do something different. I'm going to explain it now. Okay. So what I'm saying is that, okay, so now there is something a little bit confusing. The way I'm going to make the mask here and here is going to be different from the way you have to do it here, because this is how AND works. How can I make like a standard mask so that it can be used for AND, for OR, the same mask? Okay, how I can do it? The way you can do it, guys, is here, and you can use AND, but you need to flip the mask. For example, what I wanna do is the following. Look here, guys. What I wanna say, I wanna flip this bit. So I'm gonna use a normal. I wanna make a standard mask. What do you mean by standard mask? I mean, if I put 1 somewhere, so this one is gonna mark. I wanna work on this bit, either set, clear, or flip. So I want to use this way. So I'm going to make it standard. So if you put 1, 0, 0, 0, so if I use this mask, I can use the same mask to flip this bit, to clear this bit, for set this bit. Okay. This mask, it's okay for XOR. It's okay for OR. Okay. However, it's not okay for AND, because AND what you want to change has to be 0. What you don't do choose has to be once. Okay. There is a small solution here. The small solution so that you can use the same standard mask all the time. So here, your mask here, I need to calculate the ones complement of your mask. So it's gonna be like 0, 1, 1, 1, 1. Okay, and then I'm gonna do AND between these two. Okay, so this is how I can use a standard mask. So I need, instead of doing AND between this one and this one, no, I'm gonna do AND between this one and between the mask. That is why, as I'm gonna teach right now, we have two types of AND. We have AND is gonna do AND between any two numbers. For example, when I say AND, it's gonna do just AND. And we have another AND is gonna do AND between this number and the ones complement of this number. Okay, guys? So we have two types of ANDs. As I'm gonna explain right now, we have AND, for example, AND R0, for example, and R1, R2, for example. So this one is gonna do AND between R1 and R2, okay? We have another one, we call it PIC. I think PIC, I don't remember the name exactly, but I'm gonna tell you about it. So the other one here, I think PIC clear, anyway. So I have another one. The other one is gonna do AND between R1 and the ones complement of R2, okay? So in the first task in the lab, you are going to use the normal AND. Okay. The second one, I give you a mask, and I told you have to use this mask. Okay. So if you want to use a mask, if you have a certain mask, in order to make it work with AND, okay. So you should use the second kind of AND that is gonna end with the ones complement of this one. Any question? Is that clear? What I'm saying is clear or not? By this way, it's gonna be like standard. If every time you have a mask, every time mask means you have here one means you have to use 1 to mark the bits you want to change. 0, no change. So in case if you want to use this mask, you use normal OR. You have to use normal XOR because this mask can work with them. However, for AND, you have to use the AND that is doing calculating AND between the first register and the second register is going to be one's complement of the second register. We have 2. Okay. Any questions? Is that clear? Okay. So now, the second thing I want to teach right now is that I told you we can use the logic operation to manipulate some bits. Also, you can use them to check some bits. I want to check if the bit is 1 or 0. Okay, I'm going to tell you about the idea. So the idea is that, look here, guys. If I want to, in this case, you have to use AND. Only AND can work here. Okay, so AND is here. I'm explaining how can you check some bits. For example, I want to check this bit. I want to see if this bit is 0 or 1. Okay, so here I'm going to use AND. How you are going to use AND? I'm going to tell you how. Look here, guys. Because I want to check this bit, I'm going to put here 1. The bits I don't want to check, I'm going to put zeros. What is the idea here? The idea is that 0 and anything, I'm going to get zeros. So already this part, it's like I masked this part or I canceled this part. I cleared this part. Okay. So because I don't want to check these bits, just to put zeros so that you cancel them. Okay. But I want to check this one, B0. Okay. So in this case, B0 and 1, I'm going to get B0. Okay. So this is the result I get. So the result here I get, if it is 32 bits, the value of these 32 bits is either 0 or 1, right? If the value, because here I put zeros here, guys, everywhere, okay? If the value here is 0, that means B0 is 0. If it is 1, what means B0 is 1? Okay? So that's how we will do it, okay? Number 1, you are going to do AND, and then you are going to check what is the result. If the result is 0 or 1, to know if this bit is 0 or 1. Okay, guys? Any questions? Okay. Okay, so these are the instruction we have. We have AND here, as you see, guys. You are going to do AND between these two, store the result here. This is OR. You are going to do OR bit by bit between these two, store the result here. This operand here and here, they can be a register or it can be a number. But in case of a number, as usual, you have to put hashtag as usual. So here you can put hashtag, for example, 0x3 or whatever. Okay. This is XOR. Okay. So here, and every one of them should have another version, but in the other version is that you are gonna do AND with the complement of this one. Okay. You are gonna do OR with the complement of this one. So let's see here. For example, OR not. So this what's gonna happen here. You are going to do OR operation between this one and the one's complement of this one. Okay. We have another one. That's what you are going to use to in the lab, pick. So pick here means bit clear. Or actually what happens here is that AND, as you see here, guys, this is AND with the one's complement of this one. So this instruction and this instruction are exactly the same. The difference is that here this one is gonna do AND with this operand. This one is gonna do AND with the one's complement of this one. By the way, in C language, this is the operators. You have to use this in C language for AND or XOR. Okay, guys? Then I'm gonna explain these ones. Any questions so far? Okay, great. So here you just have a lot of example. You can just go through this example. They should be very easy. I don't want to spend the time with this. This is just an example to understand how this works here. So I give you some numbers. It's going to do bit by bit AND, bit by bit OR. This is pick. Again, pick. They call it pick or bit clear, but actually this one means AND not, because this one is going to do AND operation with the one's complement of this one. I'm giving you here an example. So if here this is R0. Here, as you see here, so we're gonna calculate the one's complement of R0, and then you are gonna do AND between one's complement and R0. This is the one I told you you have to use if you wanna use a standard mask. You got what I'm saying? So if you have a mask, what do you mean by standard mask? It means just the bits you wanna change, put one. The bits you don't change, put zeros. Okay. This is. So if you wanna use this mask, you can use it with OR. To set some bits, you can use it with XOR to flip some bits. However, if you want to use it to clear some bits, you have to use pick. Don't use AND, because what's going to happen is going to be the opposite. If you use AND, you are going to clear these bits, and you don't change these bits. It's going to be the opposite. You got what I'm saying? So that's why you have to use it with pick. So in the first task in the lab, you can use normal AND, because I didn't tell you what you have to do. But in the second one, the second test, I'm telling you, you have to use this mask. You have to use this mask. So in this case, you have to use this one. Okay. Anyway, any questions? Also here, I'm saying, I want you to learn the difference between these operators in C language and these ones. They are very close, right? This is one ampersand, this is two. This is one, this is two. Yeah, but this is big difference. These ones are logic for logic bit by bit logic operation, but this one you use it in instructions. Like if you have in conditions, if you want to make conditions like this one, if A is greater than 5 and this one, okay. By the way, you can also use one, but there is a small difference between them. But anyway, let's go this way. Just use two here for doing logic operations. Anyway, one of the things also here we have something we call. I'm going to explain in details in next section. Shift right and shift left. Shift. You can tell from the English name. Shift right and shift left. What it means? It means if you have this one this way. If you have this one 0 0 0, and then I want to shift left, what it means? It means every bit, the bit in position number 0 is gonna come to B1. B1 is gonna come to B0. So everyone is gonna move to the next position. That means, so here I'm gonna shift with 0 all the time. So that means 0 here is gonna be the first one. This one here it was bit number 0, it's going to be bit number 1, bit number 2. So every bit is going to be shifted one position. The last one here is going to go to the carry. So I'm going to give you more details on this one. So here we have 2 of them. So just you shift all the bits. Every bit is shifted one position. Okay? You can shift it 2 or 3, whatever, but this is the idea of shift. Okay. And we have 2 types. We have right and we have left. It depends on the direction. So if you shift this way towards your left hand, this is shift left, this left hand. Okay. If you shift this way towards your right hand, so it's going to be shift right. So I have 2 types, right or left. In C language, for sure, I'm going to explain in next chapter. I'm going to explain instructions to do shift right and shift left. I'm going to explain why we need them for sure, but also for C language, how can you do shift right or left in C language? Okay, this is the 2 operators you have to use. So if this is this way, it's like this way. This is shift right, and if it is this way, so this is shift left. As you see here, guys, I'm going to see, for example, N, you have to shift right N 2 times to the right and store the result here in variable C, right? This is the same thing. So here, this is the variable I want to shift, okay? And this is actually, this one is not going to change because the result, I want to change the value of N. The value of N, I want to shift it twice and then store the result in C. So this instruction is going to change C, right? So I give you here example. Yeah, this is N. This is the original N here. So if you shift it twice, so as you see here, guys, if you shift it twice, so that means I'm going to add 2 zeros here, and then I'm going to lose 2 bits from here. And this is the result I got here. Sorry, this is result I got here because this is shift left. That's what you are going to get here. But in case of shift right, if it is right, so actually I'm going to put these 2 zeros here if you want to shift it twice, and then I'm going to lose 2 here because all of them are shifted. Okay, and this is actually the number I got here. Okay, guys. Why? So you should understand we have 2 operations. One is called shift right, shift left. You actually shift the bits. Every bit is going to occupy next location. Okay. But why? I'm going to tell you why we need it. Okay, guys. Any questions? Look here, guys. There is something we do in C language just because it's more convenient. It's more convenient. Okay. For example, guys, I wanna change bit number 18. So I wanna manipulate bit number 18. I told you what we have to do if you wanna do that. What you have to do, you have to put 1 here and you have to put zeros everywhere. Is that okay? As we agreed, bit number 18. By the way, numbering will start from 0. This is pin number 0, pin number 1, and the last one is bit number 31. Always we start by 0. We don't start with 1. Okay. So here I wanna change bit number 18. So my mask has to be 1 here and 0 everywhere. Okay. So what is the number? What is the value? Okay. It's not gonna. There are 2 ways. One way you can calculate it. There is another way which is more convenient. So let's tell you what I mean exactly. What I mean is that, so here you have 32 bits. In bit number 18, I have to put 1 and I have to put zeros everywhere. And then you have to convert because it's going to be difficult to use binary. 32-bit binary. It's going to be difficult. So you have to convert this number to hexadecimal. Hexadecimal is much better than binary because it's 32 bits. Then you have to convert it to hexadecimal. Maybe this is going to take some time. It's not convenient. There is a much better way. We're going to do it all the time. Very easy, easier than this one. Okay. For sure, if you want to do this way, in order to get the mass, what is the number of this mass? Okay. What is the value? Okay. So you can do this way, and then you can convert it to hexadecimal because it's going to be too difficult. Although it's not wrong, but it's going to be too difficult to say 0 byte, or actually in our microcontroller we are using 2 underscore, and then you is going to use your 0, 0, 0, 0, 32 times. So it's going to be too difficult for sure to do this way. So it's more convenient or it's better to convert it to hexadecimal. Okay, guys. So this is one way. There is a better way. Instead of converting to hexadecimal. What is the better way? I'm going to tell you the better way, and we're going to use it all the time. So the better way is I'm going to use shift. For example, if I say number 1 shifted to the left, okay, 18 times. So what? So here, what this one is going to be equivalent to this one. So in C language, this one is going to be much more convenient. You got what I'm saying? Because here we are saying number 1, and then I'm going to say shift it 18 times. So if you shift it 18 times, so this one is going to come to bit number 18. Okay? So if I want to get a number where there is a 1 at bit number 18, 0 everywhere, I can use this one. And if I change this number, if I make it 17, or if I make it 30, or I make it 21, okay? Whatever number you are using, you are going to get a word where there are zeros everywhere except only 1 bit, which this number here. So here, the number you're going to put here is going to tell you which bit is going to be 1. Okay, guys? This is how easy way to create mask. Right? For sure, if you hit it and you want to write 32 zeros, okay, you can enjoy your time. You can do 32 bits zeros, okay, so 32 bits. But for sure, it's not convenient to do 32 bits. It's easier to do this one. Anyway, so in C language, if I want to do, if you want, as I told you here, you can use these symbols. You can use these symbols to do AND, OR, XOR, and so on. So let's start. Let's start with, for example, let's start with this one. Okay, I'm going to start with this one. OR. This is how can you do OR in C language. So, you know this one in C language. This one, it means variable A should equal variable A or this one here. Okay. What this instruction is going to do? This instruction is going to set bit number K. Is that okay? Because this is a mask. Okay. So if you want to set bit number 7, just put 7 here. If you want to set bit number 8, just put 8 here and so on. Okay, guys, any questions? Why? Because this is a mask. See, you are going to have a mask this way, and then you are going to have 1 at bit number K, 0 everywhere. Okay. After that, you are going to do OR operation. Any questions? Okay. Here, for example, here I'm for example, if I put here 5, that means I want to set bit number 5. So this operation will do it. It's going to set bit number 5. So if I want to do the same thing, in assembly, how I can do it? Okay, look here, guys. If I want to do the same thing in assembly, number 1, I have to use OR. I have to use OR between, I'm assuming here A is stored in R0. So A here is R0. So I need to do R0. I have to do OR operation between R0, and then I have to do it with a mask. And in this mask, I have to put 1 in bit number 5 and 0 everywhere. And then I'm going to do OR operation. Is that okay? In order to do that, I can do something like that. This is my mask here. Okay, this is the mask. This one, if you expand this one, or if you convert it to binary, you will find I have one in bit number 5, have 1 and 0 everywhere. So this is the value I have to use. So I can put this value in R4. Is that okay? And then I can do OR operations this way. Someone can tell me you put S here. Just I told you before, if you put S, that means you are going to change the flex. Actually, here I don't need the flex. It doesn't matter if you put S or not. You get what I'm saying? So here, just to change. You understand what I'm saying, guys? So here I'm going to put the mask in R4, and then I'm going to do a OR operation. Okay. So this is one way. Again, I don't like this way. If you like it, I'm totally fine. Because this one is not convenient. As I told you, you have to put 1, you have to convert it to hexadecimal. You can use the idea of shift, as I told you. So this is the idea of shift here. As you see here, guys, these 2 instructions here, these 2 instructions are equivalent to this one, exactly like this one. So here in register 4, I'm going to put here 1, as you see here, and then I'm going to shift this instruction for shift. I'm going to explain it shortly. So I'm going to shift it 5 times. So I'm going to shift this one 5 times. So after you shift 5 times, so actually R4 is going to store this number here. This number is going to be stored in R4, but just more convenient. You understand what I'm saying, guys? So instead of calculating this mass, you can just compute it this way, okay? And if you change this number from 5 to 6, so actually, so here you put 1 at bin number 6 or at bit number 6. If you change it to 17, so actually you are going to put 1 at 17. If you change it to 27, you are going to put 1 at 27. Anyway, this is just maybe more convenient way to calculate the mask. Any questions? Okay. Now I'm gonna repeat exactly same thing, but for XOR. XOR is used if you want to toggle some bits. It's exactly everything I have just explained right now. Here, you know, in C language, if you do something like that, that means this is A should equal A XOR 1K. So here, this is going to be calculated, and this is going to be a mask, a number. Okay. So what this instruction is going to do, this instruction actually is going to flip. Is going to flip bit number K, and you don't change the other bits. Is that okay? So for example, if I do something like that, so actually you are going to flip bit number 5. Again, we'll start counting from 0, 0, 1, 2 until 31. Okay. Again, if you wanna, how can you do the same thing in assembly? As I told you before, you can put the mask. Sorry, I think you can. Yeah. I think something. Okay. So again, what you can do here, you can get, but I think something is wrong in this slide. I'm going to tell you, because the mask here is just different from the masks I'm using here. This one is okay, but this one's I'm going to modify them. But anyway, I'm going to tell you what's wrong here. Look here, guys. So what I did here is exactly similar to what happened here. What I can do, R4, here, this is R4 here. I'm going to put 1 here. And then I want to shift, I have to shift 5 times to have the mask. Shift 5 times. Is that okay? And the way you can do it, if you want to shift 5 times, there are 2 ways. One way, you can just use instruction like this one to shift 5 times to create the mask. Okay, you put 1, shift 5 times to create the mask. This is one way. The other way, and this is very interesting, so the ARM processor is allowing you to combine. So if I come here, guys, so what I did here, I shifted 5 times and then I did OR. Actually, ARM processor is allowing me to combine these 2 instructions together. How? I'm going to tell you how. Look, yeah, look how I can do it using this instruction. So how, look at the last part here. The last part here, guys, it's just one operator, one operand. So this is just one operand. So what's going to happen here? So this one here, R0 should equal R0 or with this value. Okay. So this value is actually R4, but after you shift it 5 times. Look at it. So here, R4 after you shift it 5 times. So this is one operand here. So here you are saying I want to shift the value of R4 5 times, and this is the operand you have to use. Very interesting. Again, I don't want to complicate it. It's very simple. What I'm saying is that you can use 2 different instructions. Number 1, you should understand why we shift. We shift because that's an easy way to calculate the mask. You might not need to shift, but you have to calculate. If you put 1 at position number 17, what is the value of the mask? What is the hexadecimal value? Okay, you need to calculate it. Or the easy way, you can just use shift. Okay. In case if you want to use shift, there are 2 ways. One way is, as you see here, you can use instruction for shift, or the C language, the ARM processor is allowing you to merge these 2 together here in the last operand, as you see here. Maybe this is short way to do it. Okay. Here, for this one here, guys, here bit number 5. So here we have we have 4. This is the first 4. So the first 4 should be 0. We have here from 0 until 3, right? 0, 1, 2, 3. Okay. And then we have bit number 4. We have bit number 5. Is that okay? So this one should be 0. This one should be 1, 0, 0. And then everything else will be 0. I want to calculate the mask. So the mask here has to be 0, 0, 0, 0, 0, 0. Okay. And then this one, which is number 2, and then 0. Okay. This is if you want to, this mask. This is by. So this mask, if you want to use this mask this way, so actually this one will be bit number, you put 1 at the position of bit number 5, okay? So you can, the other way you can just come up with this value. For sure, this value is not correct. That's what I told you. So what this one is gonna do, you are gonna, this mask is not correct because this one you are gonna set the first bit. Okay, so that's why I'm gonna correct it. So this one is not consistent with this one, but you can use the same idea. So here you can actually, instead of using this number, you can use 20 here. Okay. Or you can put this value in a register as you see here, but again it should not be this value. Okay, so it has to be 20, just to be consistent with this example. It has to be 20 this way. Okay, you have to put it in R0, R4, and then you have to use this way. By the way, this one, the operand here, I think what you can here, you can use no more than a byte. Okay, so I can't, if it is like, if the bit here is, if your mask actually is 002 0000, I don't think it's going to be acceptable. Okay, here you can have a mask, but anyway, that's not difficult case. All what you have to do, just to put it in a register and then use a register this way. Any question, guys? So here I explain, if you wanna calculate the value of your mask, very easy. In the mask, you put 1 in the position of the bits you want to change. You put 0 everywhere. If you want to calculate it, okay, you can calculate it and you can use it this way. Maybe an easier way is just to shift, because you don't need to puzzle yourself. You don't need to convert to hexadecimal. Any questions? Okay. Now let's go to AND. How AND will be different? Everything I'm going to repeat it. Everything except one thing. What is this? I told you in case of AND, just to use a standard mask instead of AND, I have to flip them. I have to flip the mask. You got what I'm saying? So use the standard mask and then you have to flip it. Okay, that's what I told you. And that's exactly what I'm gonna do right now. So that's why if I come here, if I want to clear some bit in C language, okay. So I'm gonna use this. This is the standard mask, but I have to flip. I have to flip it before I do AND. So actually, if you know in C language, this one is equivalent to this one. A should equal A and not 1K. You should understand why I used this one. This one should calculate the ones complete, okay? Because in case of AND, okay, AND needs the ones complement of the standard mask. The bits you don't want to change, you have to put 1. But the standard mask, you have to put 0. So I'm going to flip it, right? So this actually is exactly equivalent to use bit instead of AND. You can use bit clear. Bit clear is actually AND with not. You are going to calculate, not the mask. Okay, guys, any question, guys? Anyway, also I give you several examples here. Let's look at these examples. So this example here, actually, this you are gonna clear bit number 5, and then all the other bits are not changed. You just clear bit number 5. Okay, I like it because it's just easy to use. If you want to clear bit number 17, just put here 17. If you want to clear bit number, just put here 21. That's it. Very easy to use instead of calculating the mask. Okay. Anyway, so here I give you several ways to do it. Let's go through them. Maybe this is a very easy way here. Here I'm not going to use the standard mask. So as you see here, guys, what I did, I have to put 1 everywhere because 1 means no change. This is not the standard mask. And I'm going to put here bit number, here I'm going to put 0 in bit number 5. Again, I think this mask is still not true because E here this is not bit number 5. But anyway, you can know where is the 0 here. That's not difficult, but I'm going to correct it because this is not consistent with this one. Because so actually here you put 1 everywhere, and this one is E. E means I think 0, 1, 1, 1. Okay, this is E. So actually this instruction here, you are going to clear bit number, you are going to clear bit number 0 instead of clearing bit number 5. Okay, but again, you can use the same idea. Just you are gonna use a different number here, but you can. So here I'm not gonna use a standard mask, and that's what you are gonna do in the first task in the lab. In the second task, you have to use a standard mask. Okay, that's why I used normal end. But it's just maybe it's better to use a standard mask just because it's just more convenient. The bit you want to change, you just put 1 in this location, regardless if you are doing and or. But you have to. But the way you have to do it is you have to use pick. Okay, and that's what I did. If you see here, guys, for example, register number 4 has 1 here, and then this is one operand. So what this one is going to do, this one is going to shift R4 5 times. So this one is going to be at location number 5, and then you are going to have 0 everywhere. Okay, so this is one operand. So you're going to do or, you are going to do and between. You are going to do and between R0 and not this value, because this is pick, not this value. Okay, guys, this is one way. You can instead, this is exactly here, this one is exactly similar to this one. The only difference is that here I just mix it. I just here, yeah, I'm going to use one instruction or what happened here I'm using and. So what I did here, guys, I calculated the mask here, then move not. Do you remember move not? So move not, this one is gonna copy the ones complement of this one, put it here. So ones complement, you got what I'm saying? So that's why I used normal and here. So I used normal and. Here you are using and not, because this one is gonna calculate not for this one. Gonna calculate the ones complement this one, because I told you you have to calculate the ones complement if you use the standard mask. Okay, so here I calculated this way by move not. So what happened here, I'm gonna have a normal mask here. Normal mask is like 0 0 0 0 1 sorry 0 1 0 0 0, and this value I'm gonna flip this value, I'm gonna store it in R4, and then I can use it using and here. Okay. This one and this one are exactly the same thing. The only difference is that here I used one instruction for shift. Here it's just here, this is short. Okay, so here I put the shift here. Okay, so here, as you see here, guys, I'm gonna put 1 in R4. I'm gonna put 1 this way. Okay, this instruction is gonna shift it. So I'm gonna be 0 0 0 0 0 1, right? It's a bit number 0, bit number 1, 2, 3, 4, 5. This is bit number 5. And then 0 everywhere. Is that okay? And then I'm going to flip. I have to flip this one, put it in R4, and then I'm going to use it using normal A. Anyways, there are different ways. Okay, guys, any questions? Yeah, sure. Yeah, that's a very good question. Okay. Yes. So. So the question is that what if I wanna work on multiple bits? Okay, so yes, what you can do, you can calculate the mask. That's okay, and you could put, for example, 1 1 here, and then you can calculate it and just use it. I'm totally fine with that. Or maybe because I'm a little bit lazy, so in I can write 2 instructions. Right? One instruction to flip this one, and then another instruction to flip this one. You got what I'm saying? For example, I'm going to write one instruction here. I'm going to flip bit number 7. And then I'm going to repeat this instruction again to flip number 8, and so on. So both solutions are okay, right? So either you just calculate the mask and use it, and that's totally fine, or you can just repeat the instruction. You got what I'm saying? So here, if I want to flip bit number 4, okay, I'm going to put 4 here. And then I want to flip bit number 5. So sorry, 6. So I'm going to repeat the same instruction here and put 6. So I'm going to just write more instructions, but just okay. And, or you can just use mask. I'm totally fine. Any questions? Okay. Now, I'm going to teach more instructions here we have. So the first instruction we have here, we call it, we have two instructions. One is called bit field clear, and the other one bit field insert. What is the difference between them? Okay, let's start with the first one here. If you have a word and I want to clear some bits here, for example, I want to clear starting from bit number 5 to bit number 17. So I want to clear this part. Okay, you can use this instruction. It's totally fine. You can use this one. Okay, how this instruction works, I give you example here. So this instruction is used if you want to clear multiple bits. Okay, this way without even thinking about mask, you can just use this one. So look here, guys, how this one works. So for example, here I'm saying R4, and then you have to put here a number and a number. So what is it if you put 8 and 12? What it means, what 12 means, and what this instruction is going to do? Very simple. What this instruction is going to do, this is R4. You are asking to clear starting from bit number 8, starting from 8. So this number here is the beginning, bit number 8. And then you have to clear 12 bits. So it's not from 8 until 12. No. This is the beginning. I'm going to start from bit number 8. This one, how many bits you need to clear? So starting from 8, you need to clear 12 bits. So actually, it's going to be from 8 to 19, 12 bits. So it's going to be 8, 9, 10, and so on. So here you have to say when is the beginning, which bit you want to start from this bit, and this one should tell how many bits you want to clear. You guys, any questions? This one, so also on one of the tasks, you need this one tomorrow. You need this one tomorrow. What this instruction is going to do, guys, you are going to have two registers this way. You can copy, I can copy part of this register. I'm going to copy it to another register. So you have two registers. I want to copy some bits from here. I'm going to put them in the other register. Okay. So how can you do it? As you see here, guys, for example, and you need it for the lab. So here you have R9, you have here R2, and then you have two numbers. I'm going to tell you what this instruction is going to do. This instruction, again, you want to start from 8 for 12 bits. You need to replace. Always, as you know, this is our destination. So this is the one I'm going to change. Always we do that in the ARM the instructions here. The first one you are using is actually this destination. This is the one you are going to check. So here, what this instruction is going to do, this is for R9. You want to start from bit number 8 for 12 bits. So you are going to end at bit number 18 because you 12 bits. So these bits, okay. So you are going to copy. And also you have here R2, the second one here R2. You want to replace these bits with the first 12 bits from here to here. Is that right? So replace bit 8 to 19, 12 bits of R2 with bit number 0 to 11 from R2, right? So here I'm going to replace these 12 bits from the 12 bits from here. Always here you take the first bit starting from the first one, always, but here you can control the beginning from here. Okay. Again, guys, as you see here, you have to this is the one I'm going to change R9. So here R9 here, I want to change it from 18 to 12, right? I want to copy 12. I want to copy 19 bits from here. I want to copy them here from 0 to 12. I want to copy 12 bits because you start from. I'm going to copy from 0 until 11. So I'm going to copy these 2 bits here. Okay. So one of the tasks you have in the coming lab. Okay. The coming lab, it has, I think, 6 or 7 tasks, but they are very short, very short. If you understand the lecture, and even I'm telling you what is there, so to help you. So one of the tasks is I'm asking you to copy some bits from one memory location to another memory location. For sure, as you see here, and as you see all the time, the instructions we have don't work on memory locations. That's why you have to copy, you have to read the memory location using load. You have to copy them, you have to do manipulation, and you have to return using store, right? So all the lab is going to be about memory location, but actually all the instructions are about registers. So you have to load and then do the manipulation, and then you have to use store. Okay, I'm quite sure some of you are going to forget to use store, and then you are going to run the program. You tell me no change. I didn't get the result I was expecting. Yes, you did the operation correctly, but you didn't write the result back to memory. That's why you don't see it. Don't do these simple mistakes. Okay? Any questions here? So this instruction allows you to copy some bits from one register to another register. Any questions? Okay, so here, as I said before, you have move and you have move not. Move is gonna copy register to register, and move not is gonna copy the ones complement of this one, write it here as given in this example. So I know I explained this one before, but because this instruction can be also one of the logic operation instructions, that's why I put it here. So this instruction is gonna calculate the ones complement, right? If you want to calculate the ones complement of any register, for any register, you can use this one. Okay? That's why I repeat it here. I put it here again because this one can be classified under logic operator. The last instruction, or the instruction we have here, let's see them one by one. And I think you need this one also tomorrow in the lab, okay? In the coming lab. So what this one is going to do, guys, it's called reverse order. This is a very simple one. So here, this one you are going to reverse order. So here, as you see, you have only two registers. I'm going to reverse the order of this one, store the result here. So this is two register here. So what's going to happen? I'm going to reverse the order of this one, copied here. What do you mean by reverse the order? As you see here, you can see in this figure. So bit 0 is going to come here. So I'm going to flip. I'm going to just, bit 0 is going to come here. Bit 1 is going to come here. I'm going to reverse the order. You can see it here. So bit 0 is going to come here. Bit 1 is going to come here. Bit 2 is going to come here. And so on. So I give you example here to understand it better. So for example, here, and you are going to need it tomorrow, as I told you, R0 is storing this value. So if you reverse this value, store it in R1, this is the result you will get. Okay. Can anybody guess why? Because let's take, so here actually this is 8, right? The 8 is going to become 1. Why? I'm going to tell you why. Because this 8 is actually 1, 0, 0, 0. Is that okay? No, sorry. I think, yeah. So here, what's going to happen? Yeah. So what's going to happen, guys, when you reverse the order, this one is going to be the last one. This one, next one, and then 1. So you're going to get number 1. That's why you have number 1 here. Okay, guys? So in tomorrow's lab, also tomorrow, it's not tomorrow, in the coming lab. Okay, so actually I'm gonna, you are gonna have a number, I'm gonna tell you to reverse. You may be confused, okay, because 8, when I reverse it 8, I'm gonna have 1 here, 1. You may get the correct result and you may not know if it's correct or not, okay? Why? Because if this one is 8, 8 means 0, 0, 0, 1. This is 8. When I reverse it, I'm going to get 0, 0, 0, 1. So here, if this one is 8, I'm going to get here number 1. 7 is going to become E, and so on. So let's do this one as well. So for example, here, 7 means 1, 1, 1, 0. This is 7. If I flip it, it's going to be 1, 1. If I reverse, 1, 1, 0. So this is 7. So it's going to become 1, 1, 0, which is E. Okay. Anyway, any questions? We have other instructions. Maybe I don't want to spend much time because it's just easy. So for example, this one, REV. What this instruction is doing, as you see here, guys, bit 0. So the previous one, you reverse bits. This ones, you don't reverse bits, you reverse bytes. So this byte is going to come here, and this byte is going to come here, and this byte is going to come here, and this byte is going to come here. You get what I'm saying? So it's going to just change the order of the bytes, or this byte is gonna come here, but this one for bits. Someone can ask me, okay, it looks like, well, it's that, why you are doing that? It looks like crazy. Why I need to change the order of the bits? Why this one come here, this one come here? I can tell you simply. Sometimes, for example, if your computer, or sorry, if your microcontroller, as just an example, is using Little India, okay, and you wanna send some data to another computer that is using a Big Indian, right? So you need to flip, you need to do some kind of reversing like this one to convert between Little Indian or to, and so this is just an example. You get what I'm saying? So sometimes I need to do some changing in the order like this one, okay? We have another one here, as you see, this one here. This one is gonna reverse, but not for bytes. It's gonna be 16. So as you see here, this one is gonna work. Sorry, this one is gonna work here in this one and this one. So this bit is gonna come here. 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 What this one is doing here, again, you have example. You can understand from the example here. What you can here. What this one is doing, guys. As you see here, this bit is going to come here, and this bit is going to come here, and this one is going to be signed extension for byte 0. That means if byte 0 is a positive number, if you have here is if this is if the positive number you have 0, so you're going to have 0 0 0 here, okay? So and if this one is a negative, this one is the negative number, and you have 1 here, so it's going to be 1 1 1 1. You understand what I'm saying? So number one, this byte is going to come here. This byte is going to come here, and this value is going to be the sign bit of this one. I have an example here. So let's look at this example to understand better. So what's going to happen, guys? We're going to only work on these ones here. Okay. So what's going to happen here? You're going to flip this one. This one is going to come here. So it's going to be, as you see here, 8899. And because here I'm going to look at the first byte. 9 means 1000. So this sign bit is going to be repeated 111. That's what happened. Anyway, I don't want to spend more time in that. Just very easy. The next one here, guys, this instruction are doing signed extension, right? If you remember, that's exactly what we have done before, signed and unsigned extension. We did it before using load. So we used load instructions to do signed and unsigned extension. However, when we used to load, we did signed or unsigned extension for memory location. So when you read from memory, I'm going to read byte from memory and then extend it. You understand what I'm saying? Here, I'm going to do exactly the same thing, but it's not memory. This one is going to be for register. So here I have some instruction. They are going to do signed and unsigned extension for register. So I'm going to tell you how. Very easy. So let's look at examples here. Okay. For example, in this example here, look, guys, assuming this is R0. So what is an instruction? We have two instructions for signed. You start with letter S, and we have two of them. We start with letter U for unsigned extension. Remember, in case of unsigned extension, you just put zeros. In case of unsigned extension. In case of signed extension, if the number is positive, you put zeros. If the number is negative, you put ones. Okay. So anyway, so these two for signed, these two for unsigned. Okay, why they are two? Because this one is gonna extend the byte. This one is gonna extend half a word. A byte and half a word. So let me give you example to understand better what I'm saying. Let's look at this example here, guys. Here. So actually here, this instruction is gonna do, the first instruction here is gonna do signed extension for a byte. Because this is a byte, so I'm gonna only work on this byte. I'm gonna take this byte, I'm gonna store this byte in a word, and I'm gonna be signed extension. Is that okay? So actually, 65, 6 here is actually, it's gonna be 0, 1, 1, 1, 0. So this is a positive number. So when you extend it, you are gonna put 0, 0, 0, 0. Okay, so when you do this one, so you're gonna get 0, 0, 0, 0, 0 everywhere and 65. Okay, and this is exactly what I got here. Is that okay? Okay. What if you are gonna do unsigned extension like this one here? Okay, it's gonna be in unsigned extension, we put zeros anyway. Don't think about it. Always we put zeros. Okay, as you see. Okay, let's look at this one. here I'm gonna do signed extension, but for half a word. So this is my number is here, half a word. And because this 8 actually is 1000, so here this is a negative number because I have 1 here. So when if it is signed extension, I'm gonna put 11111. If it is unsigned extension, I'm gonna put 000. That's exactly what I did. Look here, guys. So this is the number here, and this is the number here. When I did signed extension, I put 1111 here. When I did unsigned extension, I put 000. Any questions? Okay. So again, conclusion. This is similar to what I explained before. In LOOD, the difference is in LOOD, you do signed or unsigned extension for memory location. When you read memory location, but here this is one for registers, not memory location. Okay. Any questions? Okay. The last thing I want to, almost the last 2 things I'm going to explain right now. In C language, this kind of extension, signed or unsigned, are done automatically by the compiler. You don't need to do it. You get what I'm saying? I'm giving you here example to understand. So this kind of signed or unsigned are done automatically. Okay. For example, as you see here, this one we use integer. We use integer for signed numbers. So a lot, most of what I'm explaining here are done by C language. But most of them are done by the compiler. It's not by you. You don't know the details. But anyway, but here in assembly, you have to write these details. Okay? So let me explain what I want to clarify. Look here, guys. So this is when you use this one. This means you want to define a byte, and this byte is signed byte. Okay. This is similar. This is the data type. You are going to use this one here. This one is for 8 bits, 16 bits, 32 bits. Okay. But all of them are signed because this is the data type for signed. For unsigned, you are going to use something like that for unsigned. Okay. Anyway, so what's going to happen is that this is a byte. Okay. So if you say C is equal to A, C is 32 bits. A is 8 bits. So I want to store 8 bits and 32 bits. You want to do extension. Yes, the C language will do it for you. And because the numbers here are signed, so the C language is going to do signed extension for you. You don't need to write any instruction. C language will do it. Okay. Same thing for unsigned here. Okay. If this number 8 bits and this one is 32 bits, okay. If you say E, the 32 bits is equal to 8 to D, so here you are going to do unsigned extension by adding zeros. Okay. Any questions? The last instruction I have here before I move to the next section. The last instruction here, guys. What this instruction is doing is that, like here, as you see in this example, you have a register here. You have a register. I wanna just take a number here. Like for example, this is a number, and you can take any. For example, so I can take this one, or you can just. You have 32 bits. I just want to take some parts, and these are my number. Okay. And then you want to read this number, and then I want to store this number in a word. Okay. So this is we have 2 instructions, one for unsigned and one for signed. Okay. So let's see how can you do it. Okay. Look here, guys. This is so again what these instructions are doing. You are gonna copy a part of a register, store it in another register. And because this part is smaller than the register, you have to extend it. And because we have 2 types of extension, we have 2 instructions, one for unsigned, one for signed. Okay. So let's see how it works. So here, what you are saying are 3. I want to start from bit number 4 and for 8 bits. So I'm going to start from 4, which is here, for 8 bits. So this part. So I want to take this part here. So this is the part I want to get from this register. Okay. And then I want to store it in R4. That's it. So I want to take a part. of this one. I'm going to store it in R4. Okay. And then you can do it extension, or you do it. You can do it here. This one unsigned. That is why, as you see here, we're gonna put zeros all the time because it's unsigned. This one is signed. Because it is signed, I need to look at the last bit here. The last bit is 1. So I'm gonna put if. If the last bit is 0, I'm gonna put 0, 0. Okay, guys? So again, why, if you have a register, why you want to take a part of the register and you are going to consider it as a number? Yeah, because this part is actually a number, is a separate number. For example, I can give you one example. Otherwise, if this is not the case, it doesn't make sense, right? So for example, I have a register. This part of the register are connected to some pins, and you have a temperature sensor. The temperature sensor is going to put some values here. So this is the number you are going to get here, but still everything is stored in 32 bits. But your temperature sensor is only 8 bits. So you are going to be stored somewhere here. Okay, so you can think this way, right? So maybe this is my data is here, for example, and that's why I want to take this one. I want to expand it this way. Any questions? Otherwise, it doesn't make sense. If you have one number, if this is one number, I'm going to take a piece of this number. So why you are doing that? Okay, no, this is just a one case or one example. No, this part I need to separate this part because this part itself can be like temperature in this example. Any questions? Okay. I'm gonna move to the next one, shift and rotate instructions. Okay. So as I have just explained what I mean by shift, and I'm gonna elaborate now more. Okay. For example, we have shift left and shift right, logic shift left and logic shift right. You can write it this way. What it means? It means R0 equal R1 shifted to the left R2 times, whatever in R2. So if R2 is storing 1, so you are going to shift 1 time. If R2 is storing 2, you are going to shift 2 times, and so on. This one is for shift left. This one is for shift right. Okay, let's see how it works here. Look, how, guys. This is the register. We start from bit 0 until bit 31. We have 32 bits. When you shift left, actually, bit 0 is going to go to bit 1. Okay, bit 1 is going to go to bit 2. Okay, and so on. And then we're going to insert 0 here. So 0 is going to come here. 0 is going to come here. And every bit is going to be shifted 1 bit. The last one here has to go to the carry. Last one. This is if you do shift 1 time. Okay. If you shift 2 times, okay. So you are going to repeat again. So if you shift 2 times, you are going to have here 2 zeros, and then bit 0, bit 1, bit 3, and then in the first shift, bit 31 is going to come here, and then in the second one, bit 30 is going to come here to replace this one. So bit 31 is gone. So you are going to have bit 30. You understand what I'm saying, guys? Yes.
So for the previous shift,
STN?
but
No, yeah, guys, always every instruction I'm teaching or every instruction we had here, it has 2 versions. One version with S at the end and one without S at the end. I told you before, the one that has S here, that means this instruction is going to change the flags. Without S, that means this instruction is not going to change the flags. That's it. You are going to do the operation. So here, so if you don't put S here, so actually the real flag, you are not going to change the real flag. You get what I'm saying? Because without S, so the last one is not going to be stored in flag. But with S, so actually, yeah, the last one will be in, we are going to change the flag. Okay, the real flag. So you are sorry, the real carry flag. Sorry. So here we have the carry. Last one has to go to the carry flag. What I'm saying, if you don't put S, so after you do this operation, the carry flag is not going to change. Okay, but if you put S here, so actually the carry flag is going to store the last bit here. You got what I'm saying? we have here, we have two, one to the left, one to the right. And for sure, you will understand why I just need to shift the bits to the right and to the left. So I'm going to elaborate next time. Okay, guys. Right. So I have posted the lab. The lab should not be difficult. You have to do, there is a pre-lab. Please do it. In the pre-lab, number one, you have to write the programs. Number two, you have to write the expected values. So here, for example, I have a number. I'm going to shift it. So I'm expecting this value. So there is a table. I'm asking you to fill one column in this table before you come. One column about what are the expected value. If you do AND operation, what is the expected value? And you have to compare it. You have to compare the value you calculate by hand. You have to compare it with the value you are going to get after you run your program to see if they are the same or not.